Hello, ladies and gentlemen. It is me again, David, and we are going to. You will be glad to know that we're going to factor out this polynomial. Okay, and so without further ado, we're going to begin immediately by trying to find the factors of 6 and by trying to find the factors of 12 so that we can construct the list of possible factorizations of this polynomial, and we're going to then evaluate which one is the likely candidate. Okay, afterwards we'll do the table approach so you can see how that could work as well, even though my preferred approach is the one we're going to be doing first. So without further ado, let's get started. So what I want you to imagine, so first of all, you can make a table of the products that'll give us 6. So either we can have 1 times 6 or we can have 2 times 3. And we can make the factors for 12. Now, by the way, of course, we know that the factorizations are going to have to multiply to negative 12. But I'm just going to write the factors for positive 12, and we're going to make the adjustments in the sign when we write down our possible factorizations. So here, the 12, it could be 1 times 12, of course. Could be 2 times 6. It could be 3 times 4. And then if you start continuing this process, you'll see that it'll be the same ones. It'll be 4 times 3, which is already there. 6 times 2, which is already there again. And of course, finally 12 times 1, but that's already in this list. So now here, I'm going to make my list of possible factorizations here. Okay, let's do that together. Or should I do that? Okay. So in order not to make the video excessively long, I have written out all the factorizations here. Now, I'm doing this because I want to show you all the possibilities here, but I don't want you to get nervous about this because, of course, as I mentioned before, after you do a few examples, you're going to start to get a feel for what are promising factorizations and what are not promising factorizations. But I wanted to show you here the complete list of factorizations, and now we're going to test which one has the possibility of working. But the key thing that I always want you to do is always make your list of factors of the constant term and of the leading coefficient. Okay, and one of the things you'll also notice here is that in here I have made one of them positive and one of them negative to guarantee that the factors of the 12 multiply to give me a negative 12. And so you'll see that that's true for each of these possible factorizations. And as we mentioned before, as an observation that we made before about the leading term, you can see that if you go down this row, because of our choice because we of course are using the factors of 6 for the x coefficient in each of these factors, you can see that the leading term is already guaranteed across the board. Okay. So now we can start seeing. Let's look at so again, I want you to remember from last time, right? If we look at the middle term here, this will be negative 12x plus 6x. Because how? So it'll be x times negative 12, that'll give us negative 12x. 1 times 6x will give us plus 6x. So we have negative 12x plus 6x, that's negative 6x. It's not negative 1x, so we know that it's not this one, right? So we can say no to this first one. What about this one here? Look at this. This is x times 12 will give us plus 12x. Negative 1 times 6 will give us minus 6x. This one will have a middle term of positive 6x. So this one also doesn't work. So now look at this one. This will be negative 24x because 2x times 12 is negative 24x plus 3x. That one's gone. This one also will be gone by the same reason. You see, because it's going to have a 24 minus 3, so that's 21x. This is 2x minus 36x because 12 times 3 is 36. So it's 2x times 1 is 2x minus 36x, gone. 2x times negative 1, that's negative 2x plus 36x, that's 34x. That one's gone. 6x minus 12x, gone. And by the way, let me see. Oh yeah, so that one's also gone from consideration. Negative 6x plus 12x, that's plus 6x in the middle. Negative 2x plus 36x, that's 34x. 2x minus 36x, that's negative 34x, that one's gone. Negative 12x plus 6x, that's negative 6x. 12x minus 6x, that's 6x. 4x minus 12x, that's negative 6x. I'm sorry, 4x minus 18x. 4x, because 2x times 2, that's 4x. 6 times 3 is 18. 4x minus 18x, that's negative 14x. Negative 4x plus 18x, that's positive 14x. Negative 4x plus 18x, that's 14x. 4x minus 18x, that's negative 14x. 3x minus 24x, that's negative 21x. Negative 3x plus 24x, that's positive 21x. Negative 8x plus 9x, aha, look at that. Look at what happened there. Negative 8x plus 9x. That's going to be a positive 1 in the middle term. You see? It's not negative 1, but we can tell we're close. What about the next one? This is 8x minus 9x. Aha, the middle term is negative 1. We have a match here. Okay? So what I want you guys to realize is that it may look complicated, but if you make your list of possible factors and you test them, then if the polynomial can factor, you will find it. Okay? And again, as I showed you before, you can start to think of what are, again, like I said, in the previous video, I showed you how we don't have to necessarily construct the whole list of possible factors, right? Like, let's say, remember, these are going to be associated with the x. So we can think, what's x times 1 and what is 6x times 12? So 6x times 12 will give us like 72x. 72x. And 1x times 1 will give us 1x. So if we do negative x plus 72x, we're going to get 71x. If we do negative 1, if we do negative 1x, if we do x minus 72x, we're going to get negative 71x. So we can already see that the factor constructed from these two is gone from consideration. You see? What about if we did it the other way? X times 12 and 6x times 1. 6x times 1 is 6. X times 12, this is the x, this is times 12. We can see that there will be 12x. So 6x and 12x, we can see if we add or if we subtract it, it's not going to be in the 1 range. So we can already eliminate the factors made from this in either direction, in either order. So now we can try this. Okay, what is x times 6? That would be 6x. What is 6x? What is 6x times 2? That would be 12x. So we would get 6x and 12x. Aha, if you think about that, you can see that if we have 6x and 12x, again, if you add or subtract that, that's not going to get you into the negative 1 situation. Then we can try here. X times 4, that would be 4x. 6x times 3 would be 18x. You can see you're either, if you add or subtract those, you're either going to get 14x or you're going to get, what's 18 plus 4? 22x. Let me see how would that work out. You see what I'm saying? Let me see. Let me just verify that. Again, one of these is positive, one of these is negative. So let's see that again. So 6 times 4, oh wait, where was I? Oh yes, so if you have the 6x times 3, that would be 18. And if you have the 4x, exactly. So let's say, so here you have 18x and 4x. So if one of them, so depending on which one's negative, you're either gonna add or subtract them. You're either gonna have negative 18 plus 4x, in which case you're gonna have negative 14, or you're gonna have 18, or you're gonna have negative 4 and positive 18, in which case you're gonna get the positive 14x. So, but in either case, we know that that's not gonna be near negative 1. And then if we flip it, we're gonna have 6x times 4, that's 24x, and we're gonna have 3x. So when you subtract those, because they're going to be opposite signs, you're either going to have positive 21x in the middle or negative 21x in the middle, right? So we know that that's not going to be this one. So what I wanted to show you by what I'm doing here is kind of the thought process I'm using once you've done these problems a lot of times to try to whittle away what factors I want to calculate. So all of those don't look promising. So then, but I can go systematically, right? I don't want you to think that you want to rush. I think you should never rush, okay? And of course, as I said, if you practice a lot of these, you'll develop good habits, and eventually you're going to get an insight. It looks like this, and then boom, you're going to get it. So I can start coming up from here with these two. So if I have 6x and 12x, that's not going to help us. What if I go in the other direction? 3x times 3, that's 9. 2 times 4, that's 8. So let's say I hadn't written that, and I was trying what I showed you here. I would already know from this calculation that this one and this one are going to give me the factors I want if the factorization is possible. And then I would just write those. So in other words, I would have just written these probably, and then I would have tested those, right? But now we have seen that we have gotten the right factorization already, and it is this one here, okay? 2x minus 3 times 3x plus 4, okay? So originally we factored this with the intention of solving this equation, okay? I want to step back a little bit here and imagine we didn't have it equal to 0. What we have found is that algebraically, this factorized form is the same as this polynomial, okay? So these are the same, okay? Algebraically. And let me see here. And so if you had an expression like this, let's say you have a fraction of two polynomials, we're going to see that much later on. It might be the case that this is the numerator and that the denominator is also a polynomial. And you will see later that we'll be able to simplify expressions like that. And in order to do that, just like we're simplifying numbers, we can replace the polynomial itself with the factorization, okay? And so for example, let me just give you a preview of that. So in this case, let's suppose that the top was this polynomial. So 6x squared minus x plus, minus 12. And let's say it was divided by, let's say, 3x plus 4. Just for the sake of like ease, just for the sake of ease. And let's say, so let's say that we're going to see that this is actually going to happen later on. We're going to have examples like this. Let's say we want to simplify this polynomial. At first, it looks complicated, right? But what we can see now is that, I can replace the numerator with this factorization. And so we would have 2x minus 3 times 3x plus 4. And so then, just as if we had numbers, if we have the same factor on top and bottom, we can cancel them out. Okay. And we would be left with 2x minus 3 over 1. Or in other words, just 2x minus 3. Okay? So we're going to see things like this later where factoring will play a role, and it'll play a role in a non-equation context. Okay? But here, let's go back to the equation context. And if this was a little bit abstract, I'm fully understanding of that because we haven't talked about this yet. But we will see that later. And I just wanted to briefly make the point that of another kind of context where the factorization will come out. Okay? A little preview. Okay. So, but in the context that we're looking at here, at solving this equation, we can replace the left-hand side of this equation with this expression. So that is like this. 2x minus 3 times 3x plus 4 equals 0. Now I also want to do something else before we proceed, okay? I want to actually calculate, I actually want to multiply these two terms out so I can verify for you that this is in fact the factorization, okay? Okay, let's do that together. So I would multiply the 2x with the 3x. 2 times 3 is 6. So this will give us 6. And because I'm multiplying an x with an x, that's an x squared. 2x times 4, that's plus 8x. Negative 3 times 3, that's negative 9x minus 9x. Then finally, negative 3 times positive 4, that's negative 12. Then I just combine these two like terms. What is positive 8 minus 9? That's negative 1x. So I get 6x squared minus x minus 12. And remember, here I wrote negative x. And you remember that's a shorthand for negative 1x. Okay? Okay. So now we have shown that in fact this factorization is in fact the same as this polynomial. Or this quadratic. Okay? Okay. So now we're going to use this factorization to solve this problem. Okay? Okay. So we know that for any value of x, this will be a number, and this will be a number. So I have the product of two numbers, and if the product of two numbers is 0, then either this one is 0, okay? So 2x minus 3 is equal to 0, or this one is 0. So 3x plus 4 equals 0, okay? So let's look at this one. I'm going to add 3 to the left, and if I do that to the left, I do that to the right. And I'm left on the left with 2x. So 2x equals to 3. What about this one? I'm going to subtract the 4, and I'm going to get 3x equals negative 4. Okay? What about this one? Is the x by itself yet? No. So I'm going to divide by 2, and I get here x is equal to 3/2. Now what about this one? Is the x by itself? No. It's being multiplied by 3. What's the opposite of multiplying by 3? Dividing by 3. So I divide by 3 on the left, and so I consequently divide by 3 on the right. So I'm left with x equals negative 4/3. Okay? So these are the solutions of this equation, and this is how we got it by factoring. Okay? So right now what I'm going to do is I'm going to use the tabular technique to show you how we could have done it using the table. And now I'm not suggesting that you have to use the table, and if you feel that, and so you know, it's not necessary, but I do want to show it to you because I want you to have that different perspective of how you could possibly factor out this polynomial. In any case, let me set that up for us, and let's do that. So we recall that the way we figured out how to factor polynomials at all is we assumed that if there was a factorization, it had to be in this form for some numbers a, b, c, and d, that if it did in fact factor, would exist. Okay? And we saw that if you multiply this out, right, then you get acx squared plus ad plus bcx plus bd. And that allowed us to realize that the most promising candidates for the numbers a, c, b, and d are those numbers that would multiply to give us the leading coefficient, that would multiply to give us the constant term, and then we could use this number as a way to test which ones work, right? Or which of those A, B, C, and D, which are potential candidates based on satisfying these preliminary criteria, are actually the ones that satisfy the condition, if any do. And of course, that's just a fancy way of saying, what are the candidates for the A and the C? They're the members of the factorization of the leading coefficient, in this case 6. And what are the candidates for BD? They're the factors of 12. In this particular case, because the B times D would have to equal negative 12, they would be these, but with one of them negative and one of them positive. And so we're going to fill in this table together. Okay. So what I'm going to do is I'm going to start with 1, 6, and I'm going to start with 1, 12, alternating the order of these and the sign. So it's going to be, let me make sure you can see this. So it's going to be, let me get over here. Okay. So 1, 6, and then 1, negative 12, 1, 6, negative 1, positive 12, 1, 6, negative 12, 1, and then 1, 6, and then 12, negative 1. Let me see, did I get that right? Yes, exactly. You see that I've alternated the position and the sign on each of these to give us the possibilities. So now I can move on to the 2, 3. 2, 3, 2, 3, 2, 3, 2, 3. And it's going to be 1, negative 12, negative 1, 12, negative 12, 1, 1, negative 12. And then we're going to continue. If you notice, I'm continuing the pattern to be systematic. Now I'm going to move on to the second row, to the pairing of this one and this one. So it would be 1, 6, 1, 6, 1, 6, 1, 6. And it would be, let me see here. Okay, it would be 2, negative 6, negative 2, 6, 6, negative 2, negative 6, 2. Okay, and then it would be, let me see here. And then I could use the 2, 3, and the 2, 6. So let me make a separate table here for that, so we can evaluate that here. Now, by the way, one of the things that I want to do later on as an appendix to this is I want to show you how we could use a spreadsheet to play with this, okay? Or maybe a spreadsheet or maybe a computer program, okay? Even though it's not strictly necessary for this, but it's a nice aside that you can like explore how a computer could help with something like this. Even though strictly speaking it's not necessary, but I think it's fun sometimes. Okay, so let's do this. So again, we left off with the 1 6 and the 2 6. So we left off with this row. And so now what we're going to do is with the 2 3 2 6, okay? So it'll be 2 3 2 3 2 3 2 3, and then it's going to be 2 negative 6 negative 2 6 6 negative 2 negative 6 2. And then it's going to be the 1 6 1 6 1 6 1 6, and then it's going to be with the 3s and the 4s. So 3 negative 4 negative 3 4 4 negative 3 negative 4 3, and then finally it's going to be this row with this row. So it'll be 2 3 2 3 2 3 2 3, and then it'll be 3 negative 4 negative 3 4 4 negative 3, and then 4, and then negative 4 3. And then here in this column it'll be the AD plus BC. And so what we can then start to do is we can start to calculate, okay? For example, AD is negative 12, BC is positive 6, negative 12 plus the 6 will be negative 6, okay? What about the AD here? A times D here will be 12. B times C is negative 6. 12 plus negative 6 is 12 minus 6. That's positive 6, okay? A times D here is 1. B times C here is negative 72. Negative 72 plus 1 is the negative 71. A times D here is negative 1. B times C is 72. Negative 1 plus 72 is positive 71, you see? AD here is going to be negative 24 because 2 times negative 12 is 24. Negative 24 plus 3 is going to be negative 21. 2 times 12 is 24. That's the A times D is 24. B times C is negative 3. 24 plus negative 3 is going to be, let me see, 24 plus negative 3. That's 21, positive 21. A times D here is 2. B times C here is negative 36. 2 plus negative 36 is 2 minus 36, which is negative 34. A times D is negative 24 because 2 times negative 12 is negative 24. 3 times 1 is 3. Negative 24 plus 3 is negative 21. Wait, I'm sorry, what? Yes, that's right. Yes. Something went wrong here. Did something go wrong here? Oh, I recopied this one. Okay. This one's supposed to be positive 12 and negative 1. Forgive me. Okay. So then here, 2A times D here is negative 2 plus 36. That's the positive 34. Okay. What about the A times D here? That's negative 6. What's the BC here? That's 12. Negative 6 plus 12. That's positive 6. What's the A times D here? That's positive 6. What's the B times C here? Negative 12. 6 minus 12. That's negative 6. What's the A times D here? Negative 2. What's the b times c here? 36. Negative 2 plus 36 is 34. What's the a times d here? That's 2. What's the b times c here? Negative 36. 2 plus negative 36 is negative 34. You see? And then we're going to keep on going here, right? Now we already know that the actual result is down here. So what I want to do is I'm going to cut to the chase. Let's start from the bottom of this table. 2 times 3 is 6. 3 times negative 4, that's negative 12. So I have 6 minus 12, that's going to be negative 6. A times d here is negative 6. 3 times 4 is 12. Negative 6 plus 12, that's positive 6. A times d here is 8. BC is negative 9. 8 plus negative 9, that's the minus 1. So we see that it's this row that satisfies the criteria set forth by us forcing, or us attempting to force this to match this, okay? Because we have gotten that the two numbers here, the a and the c, multiply to give the positive 6. The b times the d, multiply to give negative 12. And that sum, which occurs when you multiply it out, actually equals the negative 1. Okay? And so now, and by the way, I want you to notice how I used this equation to delineate what the a represents. It represents the coefficient of the x in the first factor. What the b represents. It represents the constant in the first factor, and so on. And so when you multiply this out, you get this equation. So if you had used different letters here in a different order, you would have to multiply it out to figure out what the relationships would be when you're trying to match up this equation with our given equation to try to recover the factorization. But so here, now that we have that row, we're going to delete it, or let's not delete it, let's just go over here. Okay? So I can say, okay, I can read off the table. What's my a? My a will be 2, so it'll be 2x. What's my b? My b is negative 3 over there, so it's minus 3. Why? Because it's ax plus b. What's my c? I look at my column, it's 3. So you can see that it's cx, so it's 3x. What's my d? It's 4, you see? So it's plus 4. And from this table, we can see that those numbers will give us the factorization. And you can see that that's exactly what we got before. And of course, you could have, if you didn't know the factorization and you were using this table method, you could have just continued going down the table like a computer and figuring out which one works. Okay? And then, of course, having gotten this factorization, you could then have proceeded as follows to set it equal to 0 and to recover the same solutions we got earlier. In any case, I hope that you've enjoyed this example, and I look forward to seeing you again soon. And let me just make a brief comment here. I hope that you've enjoyed this video, and I look forward to seeing you again soon. Thank you so much.